Today we are going to discuss statistics topic, a little bit advanced concept here. It is theoretical probability distribution. I am wanting to discuss the basic idea of theoretical probability distribution, what we need normally. If x is a variable whose probability are calculated with the help of some function, then we consider probability of x is a function of x. That means in order to know the probability of x, we have a function. Now this function can be of two types. If x is the discrete variable, if x is discrete variable means it takes only some particular values or isolated value, then this function of x, this fx, if I say that is probability of x is a mass function, probability mass function. In short, we say PMF. Another idea is there, that is, if x is continuous variable, then it is considered to be density function, probability density function. But today my first target, my main target today to discuss one particular type of probability mass function, that is PMF. What is the condition of PMF? If I say, then it will be total function probability will be always, if I add, it should be always 1. All the values of x should be considered, and the probability of x is always greater than or equal to 0 for all x. This is the condition of any type of PMF, probability mass function. Now what I want to discuss today, a particular type of theoretical distribution. This is called binomial distribution. This binomial distribution is a particular type of problem, particular type of function when x is discrete, but we need two parameters or fixed values. That means x follows a variable x. We can say random variable x. Random variable x follows binomial distribution with two parameters. These words are actually used in this topic as fixed numbers. Two parameters. One is n, that is a natural number, that means start from 1, 2, 3, 4, any number, and a value which is a fraction, p. P is a fraction. N is a natural number and p is a fraction. Normally when we discuss this topic, we see that it is applied to find out number of occurrences. X means number of occurrences, number of happenings. Number of happenings, how many happenings of any particular outcome. If we are repeating n times, n means number of trials, how many times we are repeating, number of trials, and p is considered to be chance of happening in each trial. What is the chance that the happening, whatever the event we are considering, what is the chance of that event in each trial, means each repetition. So actually we have three things. X is a variable which depends on number of trials, how many times any experiment is repeated. The experiment has particular idea that there is two possibility. One is it will happen or it will not happen. So if it is not happening, then we say that is probably chance of non-happening is q. Chance of non-happening. That means if we think q, then it will be 1 minus p. So these things we must know in order to consider a binomial distribution. In binomial distribution, it's a distribution because x leads to some value of probability of x. So when we write in a table, it becomes a distribution. The formula for probability of x in this topic will be ncx p to the power x q to the power n minus x, and the value of x will be from 0 to 1, 3, 1, 2, 3 up to n. That means x is a whole number from 0 to n, but n cannot be any whole number. N is a particular number which is a natural number, more than 3 or like that, 2 or 3, more than 2 or 3. It should not be 1. Actually, this formula is connected with the algebra concept, that is binomial. If we look at a binomial algebraic concept, then we say q plus p whole to the power n. This expression is called a binomial expression because q and p two terms and n is the power. If we break this one like a plus b whole square or a plus b whole cube, that type of expression, q plus p whole to the power n, we get the expression for each term like this, one by one, term by term we get ncx p to the power x q to the power n minus x. But what about this formula? This is applicable to find out some particular probability. Let us take an example, the simplest one. A coin is tossed. A coin is tossed. Suppose a coin, and coin means a perfect coins, which is called unbiased. Coin is tossed, we mostly call it unbiased coin, 5 times. Find the probability of getting 3 heads. Now, in this case, we can apply binomial distribution. Why? We can do it without applying this formula, but it's a good scope to use this formula, because if we look at the problem, n times repeated, that is 5 times. N means number of repetition. Coin is repeated, tossed 5 times, and each time the chance of success, that is the chance of getting head, here it is happening, head will appear, that head is occurrence, that is half, 50-50 chance of head and tail. So q will be 1 minus p, that is also half. Now what we need, 3 heads. We can apply the formula, probability of 3, that means x is 3, and formula will be 5c3 p to the power 3, that is half to the power 3, and q to the power, that is also half to the power 5 minus 3. Simplifying, 5c3 is 10, 1 by 2 to the power 3 and 1 by 2 to the power 2. So it is becoming 5 by 16. So this is a problem what we need. And now we can do one more problem. Instead of coin, like a die is rolled, we can do this way. A die is rolled, and there is unbiased die. A die is rolled, a die is rolled 4 times. Find the probability of getting 3 sixes. That means 6 will appear 3 times. Now here also we can consider that n 4 times, that means we are tossing the die, rolling the die 4 times repeatedly, and chance of getting a 6, that is p, chance of getting a 6, here we are considering number of 6s, will be 1 by 6, because every time we are rolling a die, there are 6 numbers on the die, and we are wanting to get 1 6 every time, so that is 1 by 6, and not getting a 6 will be 1 minus p, that is 5 by 6. Now we have the formula to get probability of 3 sixes, 4c3, then 1 by 6 to the power 3, and q, that is 5 by 6 to the power 4 minus 3. What is happening? 4c3 is 4, 1 by 6 to the power 3 is 216, 5 by 6. Ultimately we are getting the answer as cancelling with 2, it is becoming 10 by 1296. After 1296 is this one, cancelling with 2, then it will be it can be cancelled with 4 itself, 5 and 4, so it will be 5 by 324. So this is the answer for probability of getting 3 6s, but we have used binomial. It's not that we have to use binomial distribution in all the cases of these type of problems, but we can use, like another problem, a person is hitting a target. A person can hit a target with a chance. A person can hit a target has chance 1/3, 1/3 every time. If he tries 5 times, if he trying to hit the target 5 times, what is the probability? What is the probability that target will be hit? Target will be hit 2 times. So here also we are finding that every time he is hitting the target, his chance is 1/3, and he is repeating 5 times. So the same idea, that n is 5 times, p every time he is hitting or trying to hit, his chance is 1/3. So not hitting will be 1 minus 1/3, and what we need, we need 2 times, and the result will be 5c2 1/3 to the power 2, and then q to the power 5 minus 2. So what we are getting, this is 10, 5c2 is 10, and then 1/3 to the power 2 is 1/9, and 2/3 to the power 3 is 8/27. That is ultimately 80/7 243. So that's the answer of what is the chance of getting that the target will be hit 2 times. It can be something like this. Another question we can do, chance of occupational disease in a factory. Chance of occupational disease in a factory of each worker is 25%. That means 25% chance that a worker of a factory is infected with occupational disease, 25%. We are taking 6 workers are taken randomly. Find the probability that, we can discuss 2 ways. Probability that, number 1, at most 2 are infected. At most 2 are, at most one worker is infected with the occupational disease, and the second one is at least one worker is infected. So these 2 questions we can discuss this way. Again, here what we are finding, that chance of having disease is 25%. That means p is 0.25. P is 0.25 means p is the chance of each worker to be infected is 1/4, and they are not infected with the diseases 1 minus p, that is 3/4. And we are having 6 workers, every worker has the same chance. So the question is again binomial. The first question is at most 2 means maximum, at most 1 means maximum 1. That means we can take x as number of workers who are infected, cannot be more than 1. So we have 2 cases. One is 1 worker is infected, another is no worker, because 1 or less than 1 is 0. So it will be 6c1 1/4 power 1 3/4 to the power 5, 6 minus 1, and this is 6c0 1/4 to the power 0, and then 3/4 to the power 6. Now 6c1 is 6 into 1 by 4 into 243 by 1024, and then we are getting, this is 1 into 1 by, this is 1 into 1 into, this is 729 by 4 to the power 6 is 4096. So we can simplify it and then get the result. Finally 2187 in the numerator after simplifying, divided by 4096. This is the probability of getting at most 1 is infected. The next part of the question is at least 1, and the concept of at least 1 is probability that x will be 1 or more. I have a suggestion: when it is more than 1 or more than equal to 1, then we can do one thing. Total probability in case of binomial is 1. Then if you subtract 0, no one is infected, you will get at least 1. This is a very important idea in distribution. 1 minus no one infected, or 1 minus no happening, is at least 1 happening. It will be 6c0 1 by 4 to the power 0 and 3 by 4 to the power 6. 1 minus 729 by 4096, and finally after simplifying we are getting 33 after simplifying 3367 by 4097 6. So this is a question when we can apply binomial and get the probability of any particular cases. Now one very important property of binomial is mean of the distribution. Ex is called the mean. In binomial, if you write a theoretical distribution also, distribution of probability, Ex is the mean, and in the by algebra we have proved that mean of binomial distribution is always NP, and variance we can write Vx, that is variance of x, is NPQ. These two properties we must remember for binomial. Always remember that mean is always greater than variance. Mean is always bigger than variance. So we can have some question that if mean of binomial distribution is like 5 by 4 and variance is mean is given, that mean of the distribution, the binomial distribution is given as 5 we can have a value given here, that mean of binomial distribution is given as suppose 3 and mean is 3 and SD mean is given, and SD standard deviation is 1.5. What we are asking, find the value of n in binomial distribution. So what to do? It's a very simple task in finding this type of questions. We have NP as mean, that is 3. This is the first thing, and root over NPQ is SD, because SD is root over variance, that is given as 1.5. Now if you square it, squaring this we get the whole root is removed. NPQ is 1.5 square, that is 2.25. What we can do, NP is 3, so we can replace NP as 3. So 3Q is 2.25, Q will be 0.75. Therefore P is 1 minus Q, that is 0.25. Now from 1, we can find N is 3 by P, that is 12. So this is the idea how to find out number N. And this type of problems we can have in binomial as practical problems. That's all for problems of binomial distribution today.